So welcome back to this PIC16F84 primer. We looked at the first couple of pages in the last video. In this video I'm going to look at the clock circuit and the reset circuit that we need to get this PIC microcontroller to work properly. So that was the table of contents. This was the pin out of the PIC microcontroller, and again we examined what all of these pins were doing in the last video. Here's a block diagram of the PIC microcontroller. We can see that we need to power up the PIC microcontroller. We need to connect pin 14 to plus 5 volts. We need to connect pin 5 to ground. Now, in addition to those two things, we must also connect a clock circuit into pin 16, and we must connect a reset circuit into pin 4. And in this short video, I'm going to look at a typical clock circuit that we can use that'll get this PIC microcontroller to work properly, and a typical reset circuit that we can use, which we also need to get the PIC microcontroller to work properly. So the clock circuit has to be connected into pin 16, and the reset circuit has to be connected into pin 4. Let's look at the clock circuit first of all. Now the clock circuit has to generate this waveform here. It has to generate a waveform that's low, then it switches to go high to 5 volts, then it switches back down to go low again, and it switches high to go back high again, and then it switches low to go low again, and it does this very, very rapidly. Let's say it does that every 0.25 microseconds. So that's a quarter of a microsecond. So the frequency of this clock signal will be 4 megahertz. So in this case we're having a very, very rapid on-off, 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 on-off signal. And that signal has to be connected into pin 16, which is called OSC1 of the PIC microcontroller. You can see there's a little bit of what's called overshoot and undershoot here and here in the waveform. And because this signal is at 4 megahertz, or it's switching 4 million times every second, you will see overshoot and undershoot when you look at this signal on an oscilloscope. There's 3 different ways of generating this particular signal. You could use a clock oscillator, a ceramic crystal, or an RC circuit. I'm just going to look at the clock oscillator method in this short video. So here's the clock oscillator circuit. What we have is we've got a 16-pin device, 4 of which are used. So pin 1 is really not used for anything, there's no connection to it. Pin 7 is connected to ground. Pin 14 is connected to 5 volts. And then coming out of this clock oscillator on pin 8 is this signal here, this clock signal. And that clock signal is entered or connected to pin 16 of the PIC microcontroller. So we're getting this signal that I've sketched up here at the top of this slide on pin 16 here. Now 4 megahertz means that the PIC microcontroller will execute an instruction every microsecond. So just in case you're wondering why it's 4 megahertz, that means every millionth of a second the PIC microcontroller will do some instruction that we want it to do. So it's just a convenient frequency, 4 megahertz. That's the waveform on pin 16, this top waveform at the top. If I want to check and make sure that the clock oscillator is working properly and my PIC microcontroller is working properly, I can look at the signal on pin 15, and we should get this kind of charging discharging waveform. And if that's not there, well then there's something wrong with my PIC16F84. So that's a little test point that we can test to make sure that our clock signal is working properly. So that's the clock circuit. Let's now look at the next page, and the next page I'll talk about the reset circuit. So the reset circuit has to be connected to master clear, or pin 4 of the PIC microcontroller, and the reset circuit consists of this 10k resistor wired to 5 volts, and then we've got a 100 ohm resistor in series with the 10k resistor. Normally what happens is this master clear pin is tied to plus 5 volts, and that means that the PIC microcontroller is just executing instructions over and over again. We're not resetting the PIC microcontroller. But if we do want to reset the PIC microcontroller, we press this reset button shown here. And when I press this, what I'm doing is I'm connecting ground to the 100 ohm resistor, and pin 4 will go low. And when pin 4 goes low, the PIC16F84 resets and restarts the program that it's executing from scratch. So this is the reset waveform that will be generated by this circuit shown up here. Normally, pin 4 is tied to plus 5 volts. When pin 4 is pressed, when the switch 1 is pressed, pin 4 goes low. And then when we release it, and it's probably on a spring, it goes back high again. So the PIC microcontroller would automatically reset on power up. We never wanted it to reset except in case of emergencies. And if there is an emergency, we press this reset button. And when we press this reset button, the PIC microcontroller resets and starts executing its program over again. Okay, so that was the clock circuit, the reset circuit, and we also need plus 5 volts and ground, as I mentioned earlier, for this PIC microcontroller to work properly. Right, that's the end of this short video, guys. Thanks for listening.